First hop redundancy protocol, or FHRP, solved the problem of the hosts having to configure multiple gateways on the network topology, which means that the way that the FHRP works is that the router 1 and the router 2 will have configured the same IP address on both of them, which means that that IP address that is the same is called the virtual IP address, or for short WIP, and this IP address, in this case 0.254, is going to be the same on both routers in the network topology, which means that if this computer is using this path to get out to the internet or reach out to the destination, then if this interface or port goes down, then right away this computer will go ahead and will use this other link to reach out to the standby or backup solution of the network topology. That's why having those, or this IP address that is the same for both devices, will help other hosts in the network topology to reach out to the destination, even though if this primary link goes down or it fails. So that is the logic of the first hop redundancy protocol. And it gets even better because on top of that, we have a lot of options or versions that we need or that we can use with first hop redundancies. And it all depends on the design that we have on the plan and what is our goal to achieve or to reach out to as network engineers. We have the options that are the hot standby routing protocol, which is a Cisco proprietary, which stands for shortly as HSRP. We have the VRRP, and we have the GLBP. The first one is the hot standby routing protocol. It is a Cisco proprietary, and the way that the hot standby routing protocol works is that you're going to need up to or a minimum of two devices, this one and this one, for that to be able to enable the hot standby routing protocol. Of course, the first router is going to act as the active one, and the second one is going to act as the standby or the passive router or device that is going to wait for the active router or device to go down so that this one then can get the role of the main device in the network topology. Of course, preemption is not enabled by default in the hot standby routing protocol. And what is preemption? Preemption, it is the technology or the terminology that allows a router specifically, let's say that this one goes down, and when this one goes down, of course, it's gonna take its role, this router number 2, as a standby, the backup router. And then if when this router comes back again or recover or comes back again after that recovery process, then if preemption is not enabled, then this router is not going to take the active or the main role by default immediately. So it needs to wait for this backup router, which now is the primary one, to go down so that it could just take again, or it could just retake that role of the active one that it had before it went down. So without preemption, this one needs to wait so that it could take its own old role back again. But with preemption, if it is enabled or configured, which in the case of the HSRP, you need to do that by yourself. When preemption is enabled and this one goes down, the router one, and in the moment that this router one comes back again after that outage recovery process, then this router is going to take the main role fast, immediately. And next we have the VRRP, or the Virtual Router Redundancy Protocol, and as its name suggests, it is going to provide redundancy for us, and it works really similar to the HSRP. That's why we need to remember or to know those or some differences that this VRRP has with or in comparison with the HSRP. The first one is that the main device is going to be called the master one, and the other one is going to be called the backup or the backup solution of the network topology. Of course, in case if this one goes down, then this one is going to take the role of the active device. The other crazy part about the VRRP is that preemption is enabled by default, so that if you choose to use VRRP, just know that preemption is coming in as a default thing with that full package, which is awesome. So you do not have to configure the preemption or to hard code that preemption by yourself. And the other thing is that it uses the multicast IP address of 224.0.0.18 for communication, which is another difference from the HSRP and is just awesome. So it all depends on the plans that you have as network engineers, what you're going to use, what is the main goal, so that you can choose if you want to use HSRP or VRRP for your main or your reasons that you need or that you plan to use for. And the other great thing about VRRP is that it has two options or two versions. The first one, it is the version 2, which supports only IPv4, and the other version is the version 3, which supports IPv4 and IPv6, which is awesome. So a lot of options, and it all depends what do you need to achieve as network engineer. So for the GLBP, let me change my color. GLBP stands for Gateway Load Balancing Protocol, and as its name suggests, it's going to provide load balance and then it's going to provide redundancy for our network topology. It is much better, it is much widely used or better used because it has a lot of more great stuff and features. And GLBP is a Cisco proprietary as well, Cisco proprietary. And of course, preemption is not enabled by default on this protocol as well. You need to hard code that. And of course, it is used much more in those network topologies that are just huge with a lot of bandwidth, traffic, and complexity, of course. And the other great thing is that the main device is going to be called the AVG, which stands for Active Virtual Gateway. This one is going to be that. And the backup device or the backup switch or router in this case is going to be called the active virtual forwarder. Of course, you can have more than 2 or 3 active virtual forwarders in your network topology, which is great. And so the main role is for the AVG, and the backup role is called the AVF or active virtual forwarder. So it is great. We have the hot standby routing protocol as a Cisco proprietary, which it doesn't have preemption enabled by default. GLBP is Cisco proprietary as well. It doesn't have preemption enabled by default, but it is great. You could do just load balance, you could do redundancy, and much more stuff because you can have one AVG, one active virtual gateway, and you could have a lot of more than 3 or even more active virtual forwarder doing the job that they need to do so that you can load balance, you can do redundancies so that you can have a lot of more options in your network topology to do different stuff, different manipulations so that you have your network topology in order and in full control as it should be. And then we talked about the one virtual gateway, multiple routers, which goes more with the GLBP. Gateway always stays up, which is awesome. You never need to worry about that you have only one active virtual or you have only one gateway. But with the use of first hop redundancies, if one goes down, you have the other link. If this goes down, you have the other one. As more advanced the feature or the version of first hop redundancy is, as GLBP is, you're going to have much more options. You're going to have much more manipulation processes or rows to use so that you could have much better. And even if your network topology is complex, you're going to have GLBP deal with that in the best way possible. Then we talked about the automatic failover, which is the preemption. Again, is enabled by default on the VRRP, but not on the HSRP or GLBP, which enabling preemption is not a big deal. Piece of cake. We're going to see that on the configuration process or in the configuration part of this video training. And then, of course, we have the optional load balancing, which comes in as a full package with the GLBP. So those are some of the core knowledge that you need to have about the first hop redundancy protocols. And then if you want to see what or how does first hop redundancy with its own versions work behind the scenes or in lab action, come join me in the next session or the next session of this video training, which is labbing first hop redundancy protocol. And the best way to understand the logic and the world of first hop redundancies, it is to understand how hot standby router protocol or HSRP, the Cisco proprietary, works. And with that being said, when you understand the HSRP, then the VRRP and the GLBP are going to be much, much easier to understand and to just grab that knowledge that is really rich and important to have while you're just dealing with different situations as a network engineer. So we have two routers on this side. We have router 0 and router 1 and switch 0. And I just added a laptop as some kind of host right there. And so as we can see, I have the interface gig 0/0 as shut it down. We're gonna do the no shut command to just bring alive again this interface and this path so that we're gonna see what is happening with this interface. We have a gig 0/0 with the IP address of 192.68.1.1, and on the other side, the neighboring router, which is the router 1, we see that we have an IP address as well. We have 192.168.1.2, and if we try to ping these routers between each other, we can see that we should have pings. Yeah, we do, and vice versa, of course. We should have that set up again. Yep, we do have pings. So, and if we go ahead and we check what is happening with our host on the end, which is the laptop, we're going to see that it has an IP address of 192.68.1.50 and the gateway of the IP address of the router 0. And if we try to configure or to ping this gateway, we should have pings. This destination should be reachable, and it is. So right now, everything is just working great. But if we try to understand, or if we try to just test what is the percentage that we have in our situation with the load balance and the redundancy, we're gonna see that we do not have much options on this current situation. Why? Because if we try and if we go to the laptop again, and if we just try to ping this device for a much longer time, the router 0, and we go to the router 0 to the interface 0/0, and we use the command shutdown, we're going to see something that is really interesting. We're going to see that this laptop that was trying or that was using this path until now to reach out to router 0 and eventually to the outside world, now this destination is not possible anymore because now, right now, we have an outer situation because the only path to reach out to the internet and to the outside world, it is this path. And now that we shut it down, this interface, now, this path is not reachable anymore. That's why we have an outage situation. And that's why we have hot standby router protocol, or that's why we have the FHRP in the first place. And the thing that we're going to do right now, it is that we're going to go to the interface as we are already. And we're going to try to configure the hot standby routing protocol so that if something like this happened, then we could have another path to reach out to the outside world. So let me just change this color and remove this pen. Okay, so let's go to the interface 0/0, and the command that we need to use to start this configuration, it is standby, and we need to hit the question mark so that we could see what kind of options this device has for us. As we can see, we have group number, which is really important. Let's go with group number 10, and right now we have something that is just crazy because the first option it is to select or to enable the HSRP virtual IP address, and we're gonna choose this IP address, 92.68.254, just add the command IP. And now we have some other important stuff that we need to check, and that is to set up the priority for this router, which should be the, let's say, the active router for this network topology. And the higher the priority, the better the chance for this router or for those routers to take or to be the main router in the network topology. So we're going to go with 200. And then before we check what we did with our configurations, we're going to just use another important command that we talked, or another important terminology, which is preemption, which means that overthrow lower priority active routers. As we talked already, if this one goes down, then if preemption is not enabled by default, then we're going to have problems. So that we need to enable this one, preemption or preempt, and here we go. So we have some commands to see what is happening. First of all, let me just um, bring this back to life again. Interface 0/0. We use the command do show standby. First of all, let's see what is happening. So we have this interface. It is part of group 10, which is important to notice. Then we have the state of this um, conversation or interface, which currently it is as speak. Why? Because first of all, we have this interface that wasn't up until now. Now it is. As you can see, we have a notification from HSRP, which is state change for the gig 0/0. And let me just stop this one. And if we use the same command again, we're going to see that now the state is active. We have 7 state changes and the timing that happened, the virtual IP address 1.254, active virtual MAC address, local virtual MAC address. Preemption is enabled as it should. And the active router is local, which means that this router right there, the router 0, is the one that is the main, the active router in the network topology. And we have the priority, which is 200. Now, what we need to do right now, it is do the same thing, except we need to have the priority much lower than the active one so that this device could be the backup or the passive device that is going to wait for the active one to go down so that it could take the role of the main device in the network topology. The way that we do this is the same as we did with the router 0 or the main router. We use the command standby 10, and we're gonna have to use the same virtual IP address as we talked already. We go ahead, we use them preemption, and that's it. Now, HSRP is going to notify us for this router 1 with some notifications, but until HSRP does that, we need to go to the laptop or to the host, and we need to change the gateway for this device. And it was, of course, the 1 slash or 1.1, which is the router 1 IP address for the interface. Now we need to change that to the virtual IP address that both our routers now are using. And we're gonna test that right now. Just let me see if we have, yeah, we have something on the router 1, the second router, and this router goes or went from the state of speak to standby, which it is a situation that we do or that we want to have this router be. And of course, we have as a standby this one as priority is 100. We have the other important information group is 10. And we have another really important show command that we could use just to see or to view our situation much better, which is do show standby brief. And as you can see, let me just do this one. You can see that the interface, which is 0/0, it is group 10, priority is 200, port is active or state is active, which indicates that it is configured to preempt. Local active, which means that this router is the active one. The standby is our neighbor, which is router 1. And the virtual IP address, it is 1.254. 254, and we could use the same command to the other device. We're going to see that we have some important information. Instead of having this as active, we're going to have this as standby. The priority is 100. The active is this IP address, which means that the active is the router 0, local, standby, and the virtual IP address is 1.254. And now we need to go to the computer or to the host to do the final test, which is to just stop this interface that is connected to the switch and then from the switch to the router 0, and to see what is happening, or to see if we have any kind of changes to the result and to the destination that could be reached from this laptop. So all we have to do is use the command ping and try to ping the interface or the IP address, which is, of course, the virtual IP address, same for both routers. And as we can see, right now, as we speak, let me just grab my pen. We have, again, this path is being used again from this computer because this is the active one, this the router 0. But what happens now if we shut down this interface? Are we going to have the same result as we did last time when we didn't have the HSRP configured? Well, let's find out. Let me just grab my, okay, this one. Let me go to the interface as we are already. And let's use the command shutdown. Okay. Now, of course, the traffic is going to go down first of all until this computer just realizes what is happening. So this path is now dead. There's nothing. As you can see, now the traffic that was going this side, now traffic has changed its own path and now is using router 1, which is the backup router. Because now this router is going to be the main device in the network topology. And as you saw, now the role of the active and the role of the decision making is now at the router 2, which it was the backup router or the passive router before we did the HSRP configuration. So you saw how this works on the real life. You saw that even though we have this as shut it down, now again we can reach out to the internet and to the other services that we have, and we can just enable again this port. We can see that we're gonna see that we should have some notifications in this specific router, which of course, yeah, it is from state going or went from standby to active, and we can change this. We can go to the laptop and just, okay, we're not going to stop that, but we're going to use the command no shutdown, and we're going to see how this router now becomes the active one and takes the role of the primary device in the network topology. Why? Because we use the preemption technology or option that we had. And of course, we're going to have some downtime. We should have some downtime right there. Yes, we went from the standby to the active router, and the traffic now will go from this computer or laptop to the original path that it was in the beginning, which is from this interface to switch 0 and then to the router 0 to the outside world. And as you saw, this timing right there, the request timeout, it is the time on which the traffic switched from the router 1 to the router 0, and now the traffic is working as it should. So you saw what is happening or what happens when we have configured the first hop redundancy protocols, which means that that could be the hot standby routing protocol, that could be the VRRP, or even the GLBP. And we saw what happens if we do not have those configured as well, and we saw that things could go just south really quick. And that's all I had for this week about the first hop redundancies. And thank you for watching. And I see you guys on the next one.